Understand? What would happen if I change this to cosine squared? Same thing, but it'd be cosines 1 or negative 1, right? And then you would be looking at here and here, right? So your answer would be pi k, right? Or 0 plus pi k, or pi plus pi k, right? Doesn't matter. It's all the solutions, yeah? Okay, it's 2:40. If you're happy, go, you go. If not, I'm going to hang out and do that last one. Make sure you bring a calculator. No phones allowed on the test. Only calculators, right? All right, you ready to talk about this one? A DVD has a diameter of 5 inches. 5 inches from here to here. It spins at 600 RPM. So it's spinning at 600 RPM, revolutions per minute. Revolutions per minute. What is the linear speed of a point on the edge of the DVD? Convert the answer to miles per hour. So as this spins, I don't know if it spins clockwise or counterclockwise, but as it spins, this point's moving along this curve. And the question is, what's the speed of that point in miles per hour? So there's a couple of ways to look at this problem. You can think of it in terms of like, just give me the formula, I just want the formula, or you can think about it the way I like to think about it, which is, what is it you're looking for? Speed, right? Speed is distance over time, right? That's what it is. The speed of something is the distance it travels over the time it takes it to travel that, right? So if this thing spins at 600 RPM, right? So it goes around 600 times in 1 minute. Then I already know the time here, don't I? I know in 1 minute, 1 minute is the time. I need to figure out the distance of the point. How far did that point travel? Well, each revolution, right? Each revolution, it goes around one time, right? Is the circumference of this circle, isn't it? So why don't I figure out what the circumference of this circle is? Like, what is the distance from here to here? So what is the circumference of all circles? You have to know this formula. That's the area. That's the area. Circumference is 2 pi r. 2 pi r is your circumference. Now, do you know your radius? What is it? 2.5, right? Half of the 5 inches. So I'm going to say 2 pi times the radius. I'm going to write 5 over 2. I could use 2.5. It doesn't matter. But half of that, right, is my radius. Let's multiply this together. The 2's are going to cancel. You're going to get 5 pi. You with me? That's a distance, right? This is inches. 5 times pi. If you got on your calculator to 5 times pi, that's going to be the distance around that CD. Understand? Now, every revolution, that's how far it travels. Right? That point in one revolution goes 5 pi. But how many revolutions is it doing in 1 minute? 600, right? So it's going to do 600 times that distance, 5 pi. That's how many inches it's going to go in 1 minute. Does that make sense or not? It's a totally different approach than way we did it in class. Because in class I just gave you a formula. Here I'm asking you to think through it, like what's happening. We know that speed is distance over time. We know the time here is measured in minutes. Do we know how far the point went? Well, in one revolution, it's just the circumference. Multiply that times the RPMs, that's how the distance over that 1 minute. Yes? Good, good. Let's get our calculators out. Let's do 600 times 5 times pi. And you're going to get, go ahead and use pi on your calculator. Let's get a decimal. What do y'all get? 1884. 31884.96. Did anyone else get that? You got something different? What did you get? 9,424.8 inches in 1 minute. Do we need to look at your calculator? You figured it out?
I fixed it.
Okay.
It was weird, but I got it.
Okay, so a CD that has a diameter of 5 inches, spinning at 600 RPM, the point on the edge of the circle is traveling at a speed of 9,424.8 inches every minute. Right? Is that fast? I don't know. We understand miles per hour more than anything else, right? Because we can relate to it when we're driving a car. 60 miles an hour, right? You hit a brick wall at 60 miles an hour, you're in trouble. Hit a brick wall at 2 miles an hour, you're probably fine, right? So it's something we can gauge easily. So let's convert this to miles per hour. So to convert to miles per hour, we use conversion factors. We want to get our inches to miles. So first we have to convert inches to feet. So down here I put inches, and here I put feet. 1 foot is 12 inches. I put the inches on the bottom so that my inch units will cancel. That should allow me to get over from inches to feet. Now I need to get from feet to miles. So I multiply this by, well, you need to know how many feet are in 1 mile. Anyone know? In 1 mile, how many feet there are? 5,280, I believe. Now, that would be something that, yeah, I'd probably provide that to you. If I asked you to go to miles per hour, I'd probably provide it. Well, you know what? I said you could have a reference sheet, so that now kind of, no, you'd have to know it. Yeah. Okay, yes? Feet cancel? Now we've got to miles. The only thing left to do is get from minutes to hours. So I have minutes here, right? I'm going to multiply over here by minutes on top, right? Because I want the minutes on the bottom to cancel, and hours on the bottom. And I know that there are 60 minutes in 1 hour. And that should get my minutes to cancel. And now all I have to do is get on my calculator and make sure I do this properly. On top, I need to do this times 1. You don't need to do times 1. I'm just showing you that you're multiplying all the numbers across the top, figure out what that is, and then you're going to multiply all the numbers on the bottom, multiply those together, and divide that into whatever you get on top. And y'all can tell me what y'all get. You got something? 8.93? 8.93 mph, miles per hour. Now I'm going to ask Google. 9,400 inches per minute to miles per hour. 8.9, so yeah, this looks right. So is that very fast? 8 miles an hour? That's a fast run. Okay, but That help? Okay. All right. Anything else? I'll be in my office hours tomorrow, and then before class next time, I'll be in my office hours as well. If you have any additional questions, feel free to reach out. You too. Thank you.
Did you receive the email?
Yes, I did. Yeah. So, what works best for you? Do you have time before or after? Because you want more time, right? So, before or after?
Oh, like after.
So, continuing after you finish here, if you need more time, we'll go to a different place.
Okay.
Does that work with you?
Yes, that
Okay, let's do that then. Is that the only thing we need? Just the time?
I can't remember. I can't remember. If that's like, if comes something to my mind, can I
Off the
email you?
document that, well, let me read what they sent me. We're talking about what they sent me, right?
Yes,
Okay,
of course.
let me open it up. Let me turn this off first. Do you have a minute or no?
Sure, yeah.
Okay.
I have a question.
Yes.
So for my calculator, when I punch in like the pi
Uh-huh.
stuff, it doesn't actually like solve it. So how do I get it to spit out the answer like that?
What I would do if you're ever like, just do the top, just do 5 times pi. Okay, just hit on your calculator 5 times pi and show me what you get.
5.
Okay, so now instead of doing that, do 5.0 times pi. 5.0 times pi.
Okay.
Okay, so your calculator, if you give it a whole number, it's going to leave it nice and pretty. But if you
Yeah.
give it a decimal of that whole number,
So
it's
then do
going
I need
to
to do that with the 600 or just the
just
5?
one of the numbers. That's it,
Okay.
just one.
Okay.
Yep. That is the way I have found is the easiest way to go about.
Yeah,
Okay.
that is helpful.
Yeah, these calculators have gotten so helpful that they're almost not helpful sometimes. Oh, you know what? I need to turn my video off real quick because I'm still recording.
Thank you.
Yep. Uh-huh.